So this is a video lesson on 8.2, the properties of parallelograms. We're going to specifically look at quadrilaterals where we have opposite sides, and those opposite sides of that quadrilateral are both going to be parallel to each other. So I have opposite sides, and I have two pairs that are going to be parallel to each other. Now notationally, where we had triangle, we drew a little equilateral triangle for triangles. For parallelograms, we're going to draw kind of a sideways rectangle, and then we're going to usually use the four letters of the vertices that represent that parallelogram. It doesn't really matter the order as long as you pick one spot and you go in that same order. If I start at P and then I go to Q, then I have to continue that pattern, P, Q, R, S. P, Q, R, S. Now there's 5 specific properties that go along with parallelograms. Those properties include consecutive angles, so angles that are next to each other, are supplementary. Consecutive means next to each other. So angles that are next to each other, they're supplementary, meaning that angle Q plus angle P, their sum is going to be 180 degrees. Second property is that opposite sides are congruent. If I have side QR, that side is going to be congruent to side PS. We also know that opposite angles are congruent. So again, if I'm standing at angle P then would be congruent to angle R, or Q to S. Opposite sides are parallel. That's pretty self-explanatory, especially since that's why it's called a parallelogram in the first place, part of the definition. So I know that QP is parallel to RS, for example. And diagonals bisect each other, meaning that when I draw the line segment QS and I draw the line segment PR, those two segments intersect at a point in the middle where it would then cut the segments into two congruent parts, meaning that QS would be congruent to, sorry, not QS, we're going to have to bisect that. So Q, we'll call this point A. So QA is congruent to AS, and we know that PA is congruent to AR. We can then kind of understand, since these are bisected and they share the point A is the midpoint of those two segments. A is the midpoint of QS, and it's also the midpoint of PR. So now that we've written down those properties, let's go ahead and try a couple example problems together. In example 1, ABCD is a parallelogram, and given its parallelogram, then we know that the properties are going to be true. Now remember, a quick way to remember our 5 properties is the first letter of each of those properties starts with a C, O, 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 D. So it kind of sounds like cooties. So that's my quick way of remembering my 5 properties, cooties. So let's go ahead and first label the information that they give me. With my highlighting tool, or maybe with a pencil, I'm going to underline the fact that the measure of angle ABD is 65 degrees, the measure of angle CBD is 45 degrees, the length of AE is 5, the length of BC is 8. Using that information, let's find the measure of the following segments or angles. So the first thing I'm going to do is I'm going to go ahead and label my information that they gave me. They told me that angle ABD is 65 degrees. So with my pen I'm going to trace ABD, DBA. That angle right here is 65 degrees. They also tell me that CBD D that angle is 45 degrees. Those are consecutive angles. So by finding that sum of those two angles, I would know the measure of CBA. That might be helpful later on. AE, the length of A to E, is 5, and the length of BC from here to here, this length is 8. So given that information, let's go ahead and find the missing parts. AD is the segment length we're trying to find. AD is located right here, from here to here. And AD is a side that is opposite of the parallelogram to BC. And if those sides are opposite, that means they're going to be congruent using my cooties. Opposite sides are congruent. So I can say that if BC is 8, then AD is 8. EC is right here, and EC is obviously on the diagonal on A to C. And if I'm trying to find EC and I know that EA is 5, that would make EC also equal to 5, since diagonals bisect each other. The measure of angle ADC is what we're trying to find next. ADC. So ADC is the large angle here. I'm going to draw that through it. So this angle would be opposite of this angle, which would be putting my two smaller angles there together. So I'm going to go ahead and take 45 and 65, add them together, and I'm going to get 45 plus 65, and the sum of those two angles is 110 degrees. So if angle CBA is 110 degrees, then the opposite angle, CDA, would also be 110 degrees. Let's find the measure of angle BCD. Next, BCD. BCD, that would be this large angle right here. So if I'm looking for angle BCD, that angle is next to or consecutive with angle CDA. So if those angles are consecutive, then if I have two angles that are consecutive angles, then they are supplementary. So that means if this angle, ACDA, is 110 degrees, then if I go ahead and take away 180 from that, I should find my other angle of 70 degrees. So angle BCD would be 70 degrees. Last angle we're trying to find here is angle BDA. BDA. And that would be this small angle. Now, if I know to find this angle that this is a parallelogram, that would mean that side AD is parallel to side BC. Since they're parallel to each other, their alternate interior angles would then be congruent to each other. So if this angle is an alternate interior to this angle, and they're made up by parallel lines, then if CBD is 45 degrees, then angle BDA would be 45 degrees. Now go ahead and pause the video at this time and try example number 2. Take your time, work with a partner if you need to, or check out the previous example, and see if you can find the given angle measures inside this figure. When you're done trying the problems, go ahead and check them with the answer keys that I put up right here. So there's your answer key for example 2. Go ahead right now and check the answers and mark the ones you got right or wrong. Remember, when we're looking at parallelograms where we have diagonals drawn through them, when we draw both diagonals, BD and AC, through my triangle, it creates 4 smaller triangles. And then we're going to have to remember back to our examples of vertical angles. Since this angle is 117, then this angle would be 117. We would also know that 2 adjacent angles formed by a line would be supplementary. So if you were trying to find angle AED in number 14, you would then go ahead and take 117 away from 180, and you would find the other angle of 63 degrees. Also remember with parallel lines that opposite angles, so like this angle would be congruent to this angle, and 23 would be congruent to 23. And also remember, once you find two angles of a triangle, you can always go ahead then and add up the two you know and subtract it from 180 to find the third missing angle. Let's go ahead and turn to the second page. And now we're going to go ahead and solve for variables inside parallelograms. Alright, so example 3, let's go ahead and look at specifically example 1 in example 3. We want to find x, which is this angle, and we want to find y, which is this angle. Since we know that all of these figures are parallelograms, then we know that Cooties applies. Consecutive angles are supplementary, opposite angles are congruent, opposite sides are congruent, opposite sides are parallel, and that the diagonals bisect each other. So, knowing those 5 properties, if this angle is 72, then its opposite angle, y, would be equal to 72. And if x is both adjacent or next to y and 72, then x plus 72, those two consecutive angles would be supplementary. They would add up to 180, which means that x would be equal to 108 degrees. Make sure you box or circle your final answers to denote that you're finished. Here we have a parallelogram. We'll mark that in red. This parallelogram is drawn, but it also gives me two diagonals that bisect each other. So, using Cooties, we know that opposite sides, 7y plus 1, would be congruent to 6y plus 10, because opposite sides are congruent. When we solve for y there, we subtract 6y to the left-hand side to get y. We subtract 1 from both sides so that y would be equal to 9. Since the diagonals bisect each other, 3x will be equal to 2x plus 10. When they bisect, that makes the two smaller segments congruent to each other. Subtract 2x from the right to the left, that gives me x is equal to 10. Looking at 3, 4, and 5, let's go ahead and attempt these together. If you feel like you're getting the hang of things, go ahead and pause the video and work ahead and try to fill in what is my work as you're going through it yourself. So since these are parallelograms, opposite sides are parallel, but they're also congruent. So that means 25 would be equal to 8g minus 3. I'm going to add 3 to both sides to get 28 is equal to 8g. And then when I divide both sides by 8, I end up with a fraction, and I can go ahead and rewrite that as 28 over 8, or I can reduce it down to 7 over 2. 7 over 2. To find f, we're going to have to understand the relationship between this angle and the other angle they give me. These two angles are complementary, they're consecutive, they're next to each other, so meaning that their angles, when I add them together, are going to add up to 180 degrees because they are supplementary. 72 plus 30 is going to be a 102. When I take away 102 from 180, I get f is equal to 78. Boxing your final answer. Looking at number 4, here we're given segments which are along the diagonals, meaning that if I have a diagonal and a different diagonal of that same parallelogram, they bisect each other, making the smaller segments congruent to each other. 9 is going to be equal to 2n minus 1. And also, m plus 8 is going to be equal to 3m. Once we set up the relationship, solving is pretty easy. We're just going to go ahead here and add 1 to both sides of this equation to get 10 equals 2n, divide by 2, and n equals 5. In the second equation for m, I'm going to subtract m from both sides, giving me 8 is equal to 2m, and when I divide by 2, m equals 4. Example number 5, we have a very similar type problem with diagonals, so go ahead and pause the video or work ahead here and see if you can find the values for k and j, which would make these diagonals bisect each other. This segment would be congruent to this segment, so k plus 10 would be equal to 6k. Subtract k from both sides, and 5k would be equal to 10. When I divide by 5, k makes 2. For j, I would set 3j equal to 5j minus 9. Here I'd probably actually subtract 5j, and that would give me a negative 2j on the left-hand side. And that would be equal to negative 9. And when I divide by negative 2, negative by a negative is positive, so I get 9 divided by 2, or 4/5. Or, sorry, not 4/5, 4.5. So let's go ahead and look at these first 5 examples. In each case, we had to apply the 5 properties and find the missing variable to make those properties true. Here in 6 and 7, we have word problems where we're going to have to sketch a picture, label the given information, and then find what is missing in the problem, or what they're asking us to find. So in example 6, we have a parallelogram, W, X, Y, Z. So we're going to sketch just a generic parallelogram. Do our best to make the opposite sides parallel to each other. We're going to start here and go W, X, Y, Z, just making sure I label my vertices in order. Angle W is 50 degrees more than angle X. And it looks like I labeled my picture a little incorrectly, since W is going to be greater than X. So let's go ahead and relabel this. Let's put X here, put W here, put Y here, and Z here. So if W is 50 degrees more than angle X, 50 degrees more, if X is some value, we don't know, let's say it's X degrees, then W would be 50 more than angle X. So it would be 50 plus X, 50 more than X. They want us to find each interior angle. They want us to find the measure of angle X, obviously. They want us to find the measure of angle Z, which are going to be the same, the measure of angle Y, and the measure of angle W. So the first thing I need to do is, based off the 2 angles that I know of with respect to X, I'm going to set up an equation for those 2 angles. So here's X and here's 50 plus X. They are consecutive, so in cooties, that means those consecutive angles are supplementary to each other. Means that their sum is equal to 180. If I add up my like terms, I get 2x's plus 50 is equal to 180. And when I subtract 50 from both sides of the equation, I end up with 2x being equal to 130. When I divide by 2, x is equal to 65 degrees. Now remember, that x represents angle x, so that means angle x up here is going to be 65 degrees. Opposite of x is z, so z would also be 65 degrees. And since w and y are both 50 degrees more than those 2 angles, I'm going to do is add 50 to 65, and the last 2 angles are going to be 115 degrees. So here we get box's answers. Those are my 3 interior angles. You're going to see there's a special relationship, especially when you add all 3 of those up. What is the sum of these 4 angles? So go ahead and take a moment and see if you can figure out that sum. And I think you're going to be interested in realizing later on in this chapter, or previous chapter, when we talked about 4-sided figures, what did the sum always have to add up to? Well, in this case, for quadrilaterals, they have to add up to 360. So that's kind of a little self-check, I guess, if you're working on that problem. Go ahead and pause the video this time and try number 7. See how you do, and then you can kind of follow along with me afterwards, after everyone's gotten a chance to kind of try it on their own. Let's go ahead and draw our picture. We know that G is 25 degrees less than H. G and H are consecutive angles. So let's make the G angle the smaller of the 2 angles that are consecutive. So we'll draw a figure here. We'll put G right here. We'll put H right here. And we'll keep going in order. E and F. So E, F, G, H, E, F, G, H. Perfect. We know that G is 25 degrees less than angle H. So if H is X degrees, then G would be 25 less than that. It'd be X minus 25 degrees. So since these angles are supplementary, because they're made by consecutive angles in the parallelogram, that means that X plus X minus 25, that sum is going to be equal to 180. First thing I'd probably do is combine my like terms and add 25 to both sides. When I add 25 to 180, I end up with 205. And when I divide by 2, I get a decimal, which ends up being 102.5 degrees. So again, they want us to find each interior angle. So if angle H is opposite of angle F, they're both going to be equal to X, which is 102.5 degrees. And then that makes angle G and angle E congruent to each other. And they would both be 25 degrees less, so they would be 77.5 degrees and 77.5 degrees. Again, checking to make sure that those four angles all add up to 360. That's our lesson on 8.2. So go ahead and rewatch that if you weren't quite sure on a certain part. Be ready to ask your teacher questions next class if you weren't quite sure. And then also make sure you try the practice problems in your practice packet on this note section on 8.2. Good luck.